Welcome to our class. In this video, we will look at generative AI, large language models, and prompts. We have already looked at many of the things that AI can do for us, from analyzing and processing data, summarize and extracting content, translating and converting between languages or formats, classifying and categorizing information or other types of data, making recommendations and personalizing experiences, automating and streamline tasks, predicting and forecasting, enhancing and refining such as spell check and grammar, detecting and monitoring such as security, controlling and operating such as robots and cars. Today we will look at a very useful thing that AI can do for us, and that is generating new content. And we're referring to text, code, images, video, and audio. Generative AI is the field of artificial intelligence that generates or creates original content, such as text, images, video, audio, or software code. It does this in response to a user's prompt or request. This prompt or request is text or voice. Behind the scenes, it uses machine learning models which are based on deep learning algorithms. A large portion of our generative AI uses large language models, and they are a category of deep learning models trained on immense amounts of data which are capable of understanding and generating natural language. Again, we use the machine learning and transformer architecture behind the scenes to do this. So these large language models understand the spoken voice and the text language that would be entered into a prompt. The main idea behind a large language model is that it is trained to predict the next word in a sequence. So this is the foundation of how large language models are built. I would like to make a distinction between generative AI and large language models. Generative AI is a broad category that generates content. It can be text, images, video, sound. LLMs only generate text content. It can be text, it can be summaries, it can be an outline, it can be a document, it can be code. While LLMs are generative AI, not all generative AI are LLMs. I would also like to add several of the LLMs out there today are capable of generating images because they work with an image model also. So large language models are responsible for the explosion of AI in 2020, which is not that long ago. Okay, due to the progress in natural language processing, the ability to process natural language, and machine learning. Also, the GPU processor and advanced hardware have enabled the large language models to be able to perform as they are performing today. ChatGPT is the most common example of a large language model. It stands for Chat Generative Pre-trained Transformer. It is credited for the AI boom, released in late 2022, which is barely 3 years from the date of this recording. By January of 23, a few months later, it had attracted over 100 million active monthly users, which surpassed the growth rates of apps like TikTok and Instagram. It is the most common example of generative AI and the most common example of an LLM. Most people are very familiar with ChatGPT. So now you have a better understanding of what it is in perspective of this concept of AI. I would like to go over a little bit of the technical process in which LLMs operate. We have this concept of the input text being broken down into tokens. The token is typically a word, or it could be a few words. The tokens become numerical embeddings, which are technically vectors. Okay, these vectors are processed through many neural network layers using this transformer architecture. The transformer architecture has an attention mechanism which enables it to focus on relative context to weigh the importance of one word against the other. Again, the whole point of this is to predict the most likely next token, to predict the next word. So when ChatGPT is answering a question, this is how it got to answer that question. Every word that it replied back with, and it could be several hundred words if it's generating a document, was put there one by one through this process. LLMs, or large language models, are actually computer programs that run on a computer. However, they are referred to as models. They undergo a training process which enables them to understand, recognize, and respond in human-generated language. Three parts of this training process. The first is self-supervised learning, where it starts becoming familiar with the data and learning to predict the next word by the probabilities of one word coming after another. Then it goes to a supervised learning process where it will actually follow the instructions to respond to specific requests, and then a reinforcement learning where it's guided toward producing more desirable results. So if you were to go into AI from a development point of view, you would be training these models using machine learning and algorithms. So we have machine learning that trains the models to predict the next word based on the data and other features. Deep learning works with the neural networks to help the model to learn patterns from the data. There are some limitations of large language models, so keep this in mind when using ChatGPT, Gemini, or another AI tool. Number one is accuracy. These models are trained primarily on data from the web, and anybody can publish anything on the web. That does not mean it's true or accurate. Therefore, LLMs can produce false information. This is known as a hallucination. This concept that LLMs can hallucinate, meaning they may give you an answer that is totally irrelevant. They are trained to try to please us, and they will do everything they can to answer our question. They also have limited reasoning skills. While they are good at understanding and generating sentences because they understand natural language, they're not that great at solving complex math problems. Their knowledge is limited. They are trained on data from the past. They don't have access to the most current information out there. Some LLMs can use a technology called retrieval augmented generation, or RAG. This actually connects them with an external knowledge base, enabling more accurate, up-to-date, and reliable responses. Their output can be biased. Again, they're trained from a lot of different data. That data can have a bias in it. and therefore the content that they generate could be stereotypical, prejudicial, or discriminatory. There are copyright issues. Again, they're trained on internet data, some of which is copyrighted, and they can use that copyrighted material in their response. Privacy is another issue. If they happen to be trained on personal or confidential data, they could accidentally leak sensitive information. So you always want to verify the information that you get when you're using an LLM. Don't just assume it's accurate. Make sure that it is credible and unbiased. The most popular LLMs are Google's Gemini, OpenAI's ChatGPT, Anthropic's Claude, and Meta's Llama. Gemini, ChatGPT, and Claude are all free to use. You do not need to sign up for an account with Gemini or Chat. However, you do with Claude. Llama is integrated into some of their applications, and you will be using it in that respect. So these are examples of generative AI. LMs generate content, they are generative AI, and these are the most popular LLMs in our world today. We also have generative AI models that do not use an LLM. Remember, we can generate images, video, and audio. So we have specific models to generate that type of content. Some of these are called diffusion models, generative adversarial networks, variational autoencoders, and there are others. They focus on modeling the underlying data rather than predicting the next token in a text sequence. Remember, LLMs are all about predicting the next word. These models may use an LLM to understand the text prompt because we typically do ask it to do something for us, such as creating a video. And again, some of these LLMs work with these models so that they can generate images such as ChatGPT and Gemini. These are some of the more popular image models: Stable Diffusion, Midjourney, DALL-E 3, which is integrated with ChatGPT, which is how Chat generates the image. Chat isn't doing it, DALL-E is doing it. And Nano Banana, that's Google's AI model for image generation. That's how Gemini generates images. And I have used ChatGPT and Gemini to generate many images in this class. Some of the popular video models: Sora, which is OpenAI, Runway, and Google's Veo. You may come across video editing software or video creation software on the internet, and it might brag about how it's AI powered, and the chances are it's probably using one of these models. Two popular audio models: Suno AI and Stable Audio. You would probably need to set up an account with them, although you probably can get a free account. And I have seen some results from Suno, and they're pretty amazing. Or I guess I should say I've heard some results from Suno. Now we come to the prompt. This is where you ask it a question, tell it what you need, what you want it to do. The result you will get will be as valuable as the input of the prompt, how you phrase the prompt, how specific you are. Okay, so a prompt is the input the user gives the AI tool. It's usually a question, a request, or a statement. Prompt engineering is the act of trying to come up with the prompt that will give you the output you want. So to get the response that you want, you need to give the AI good instructions. No different than working with a search engine years ago. The better refined your search term was, the better results you would get. The same thing goes here. There is a lot of information on structuring a prompt, a lot of different frameworks on criteria that you should be using. I will just go over some basics here. Okay, first of all, you want to ask it. What are you asking it to do? Okay, be specific. You want it to do something. Context. What does the LLM need to know to be able to give you an accurate response here? Constraints. What constraints need to be followed? Tell it what not to do also. There are many times I'll ask for something and I see what it gives me and it's like, no, that's not what I had in mind, so I have to go back and refine my prompt to be more explanative. Another option is an example, to give it an example of the output that you might be happy with, so it has an idea of what you're looking for. Another way to structure the prompt would be to set a persona, the role you want the AI to play. For example, I am a community college instructor. Do this for me. The task, what task you want it to do. Is it a list? Is it a summary? The content, what information does it need to know? And the format. And the format is actually sometimes important. How do you want the response to be formatted or presented? Do you want one column, two columns? These models are trained to work with different types of prompts. So in the development world, you may come across these terms, zero-shot prompting. This means that you're really not giving it anything specific, so it's going to rely on the data it was trained on for its answer. Few-shot prompting means you're going to give it at least one example of the desired output. So it's giving the model a little bit more structure of the expected response. Chain of thought prompting. That involves guiding it. So instead of providing a direct answer, the model will break down the problem, analyze each part, and then provide the answer. So you might want it to go through the process that it went through to derive the answer.